Hello dear students, welcome again to the tetrahedron chemistry classes. So this is my next lecture on the polymer series, and you know, if you are following my lecture series, then you know I am discussing the rubbers here, and in the earlier two classes I have explained the Buna S rubber and the Buna N rubber. Now I am going to explain another synthetic rubber, and the name of this rubber is neoprene, right? It is a neoprene and it is also known as the grade M rubber. As I already told you, in case of your butadiene styrene rubber and butadiene nitrile rubber, this GRM for neoprene is the American system of the nomenclature. Okay, this is the American. This is basically done in the American market, not here actually, right? So neoprene is quite simple. See, I know you are quite aware about the isoprene, right? Then isoprene is actually the main product in the terpenoids, main actually building block of the terpenes or the terpenoids here, right? Isoprene. And you know, in the isoprene is what? Basically isoprene is the 2-methyl 1,3 butadiene is the isoprene, and when you replace that methyl with the chlorine, then it will become the neoprene. Okay, so chloroprene, sorry, not neoprene, it is the chloroprene. Okay, and when you polymerize this chloroprene, then you will get your synthetic rubber, which is known as the neoprene. Okay, so you can see the neoprene, also known as the polychloropene, right? Polychloropene or the polychlorobutadiene or the duprene. Duprene is the trade name. Okay, these are the different names for this neoprene. How we can prepare this neoprene? Neoprene or the polychloropene is prepared by the polymerization of the chloropene, which is 2-chloro-1,3-butadiene. Here free radical emulsion polymerization would occur, and this will actually, you see, this double bond gets break here, one electron will shift here, another electron will shift on the right hand side carbon atom, making this carbon as the active center. And similarly, this particular double bond between the carbon number 1 and 2, this will break here, and one electron will shift onto the left hand side terminal carbon atom, and one electron will come here. So double bond will present here now, and these are the two active centers, and the reaction goes on and it will end up to the neoprene. Neoprene is basically the trans kind of the is having the trans kind of the stereochemistry, the earlier ones, right? And in the last lecture I have missed this particular point, but here I am going to see, if I go back, right, this was my last one, right? And this was your earlier one. Okay, so these are the two rubbers which I explained. So जाना नहीं था इसमें, खाली आ गया. So this neoprene is trans in nature, unlike your natural rubber. So what is the meaning of the trans? Trans means this is the double bond, this CH2 and that CH2 will have the orientation on the same side. If I can draw this for you, right there, you can see here, this is carbon, double bond carbon, right? And this is the hydrogen here, this is the chlorine here, and then this is the CH2, and the chain continues, right? Chain continues from this end as well, and this is your CH2 and here, and N is the degree of polymerization. So you can see here, this CH2 and this CH2 actually in the natural rubber are on the same side, but in the you can see here in this neoprene, this would be on the opposite side. So I can erase things here, okay, like that. Right, so here you can see this is my CH2 and this is my hydrogen. So these two are having the trans relationship, right? When they have the trans relationship, that means this is the neoprene. This you need to understand. Okay, I hope this is quite clear. So the vulcanization of the neoprene is different from that of the other elastomers because it can be vulcanized by the heat alone. There is no requirement of the sulfur, right? Or simply on the application of the heat, it can be vulcanized. That means the cross linking would be there if you subjected this neoprene to the heat. Although some types are polymerized in presence of the sulfur, which introduces the cross linking in the polymer as well. Neoprene can also be vulcanized using the zinc oxide or the magnesium oxide. This is different from the other two one. And what are the properties? Properties are quite important again. You can see neoprene is closely related to the natural rubber and can replace rubber because similarity in the properties of the two, right? First of all, neoprene has the superior resistance to the vegetable and the mineral oils. Okay, so this is the important property. It is superior to natural rubber as far as aging and the effects of the high temperature are concerned. That means the aging would be quite slow in case of the neoprene compared to the natural rubber, and also where the temperature is high, so it will this neoprene will survive to much extent, to actually longer years compared to the natural rubber. Number 3, neoprene is soluble in the polar solvent. Of course, the chlorine is there in that case, right? If I go back, you see this chlorine is there, this hydrogen is there, so a little bit of polarity is there, right? When due to this polarity actually, so it is quite soluble in the polar solvents. This I have written over here. Number 4, vulcanized neoprenes have high tensile strength up to 3500 to 4000 psi per square inch is the unit in the absence of the carbon black. When carbon black is not there, then the vulcanized neoprene has very high tensile strength. Okay. Number 5, vulcanized neoprene is extremely resistant to the oxidative degradation if suitably protected. Okay, this is another very distinct advantage of this one. Number 6, it has a good weathering and ozone resistance. Of course, this ozone will not react in case in case of your Buna S rubber. In case of the Buna S rubber, it would be readily attacked by the ozone environment, but in that case of the neoprene rubber, that ozone actually will not affect this rubber. Okay, so it has good weathering conditions when you have the weatherability, when you have the ozone environment as well. Okay, it has got the excellent oil resistance through the inferior to nitrile rubber, but better than the natural rubber or the SBR, right? It has a good oil resistance properties than the natural and the good rubber, but it is see, for nitrile rubber compared to the nitrile rubber it is quite inferior, but for other two it is better, right? Natural rubber and SBR, better than the SBR in butadiene rubber and natural rubber, but its oil resistance nature is on the lower side or the downgrade side when it compared to the nitrile rubber, butadiene nitrile rubber. These are the important properties. Now there comes the applications, right? It is used in the oil resistance wire and cable coating, industrial houses, shoe soles, etc. Its latex is used for the manufacture of the gloves and the coated fabrics. Okay, and it is used for making the tubings for carrying the corrosive gases and the oils, used in the manufacturing of the sponges, conveyor belts, lining of the reactions, vessels, etc. Right? You can see this is the neoprene suit, which generally the divers, scuba divers and other are actually others use this particular one, very important one. Okay, and then you can see it is high performance adhesive. It can be also used as the high performance adhesives as well, and these are the sponges, right? And similarly in the last class I have also explained, I have also shown you the conveyor belts and linings, all these things. So roughly properties are same for these rubbers. So I think this would be quite sufficient for you when it comes to the elastomers. So elastomers starts from their natural rubber, and then the vulcanization process of the rubber, and the three important or types of the synthetic rubbers, and this is very, very important for the various examinations point of view. Okay, I hope you understood the lecture well. If you understood the lecture, please like the lecture, and if you are watching my video for the first time, please subscribe the Tetrahedron Chemistry classes. I'll meet you in the next class. Thank you very much.